Today we're talking about solving systems by graphing. Throughout this chapter we're going to show you 3 different ways to do them. The first method is by the graphing method. A system of linear equations is a set of 2 or more linear equations in the same variables. So most of the examples you'll see we're going to be doing this year are x's and y's for those 2 variables, but you can have them in many different variables as long as both equations have the same variables. So an example is the following here. So this would be a system where we have 2 different equations that are working together. So equation 1 would be x plus y equals 7. The second equation, 2x minus 3y equals negative 11. Together as a pair of equations, they make up a system. A solution to a system is an ordered pair that is a solution to each equation in the system. So to be a solution to a system, the ordered pair has to be a solution for both equations. Not just one, not just the other one, but both. So let's just try some different examples here. So first, checking solutions. So tell whether the ordered pair is a solution to the system or not. So here we have the system that we just showed above, x plus y equals 7, 2x minus 3y equals negative 11. And we think the ordered pair that's the solution is 2, 5. So how would I know? Well, the first one would be this. I would take the 2 and the 5 and plug it in to that first equation. And I check to see if it works. Well, 2 plus 5 is 7. The other side is a 7. So that works. So I also need to check it in the second equation. So for the second equation, I have 2. The 2 goes in for the x, minus 3. The y becomes a 5, and it has to equal negative 11. So then I would use my order of operations here. And lo and behold, it also works. So because it is a solution to both equations, then yes, this is a solution as a system. So let's look at the next one. So if I plug in my x and my y, the first equation is going to look like negative 2 times negative 2 minus 4. Does that equal 0? 4 minus 4. So yes, the first one works for sure. But again, remember, I need it to work for both. So I'll move on to the second one. So now the 0 goes in for the y, negative 2 plus 4. 0 does not equal 2. So it does not work for the second one, which means the answer is no, it is not a solution. So even though it worked and was a solution for the first one, it is definitely not a solution to the second one. Has to be a solution to both, like letter A, not just one or the other. So with the overview of a system solution, now let's get into the graphing method. So the solution of a system of linear quantities by the graphing method is the intersection point of the graphs. If you think about it, all the points of one part of the graph would belong to one equation. All the points on the other part of the graph would belong to the other equation, but they would share the same point for the intersection of the 2. So let's just see how that works. So here are the 3 steps that you would follow. Step 1, graph each equation in the same coordinate plane. We need to see them on the same one to make this workable. Step 2, estimate the point of intersection. This is where it's important that you are drawing nice straight lines. You're really trying to make your graph as accurate as possible so that you can see where they are crossing. And then thirdly, you want to check the point from step 2 that you would say is the solution by plugging it in to make sure it works for both. just like we did a second ago. So let's go and do that. So here we have an example. We want to solve by the graphing method. So both of these, again, would be in our y equals mx plus b. Right? So it's in the standard form. We know that this slope and the intercept would be something that we can graph pretty quickly. So let's kind of do that. So here's my first equation. I would go to 5 to draw my y-intercept, and then I would come down 2 and forward 1, and I would do that several times to make sure I saw the best situation that I can for my line to be as straight as possible. Not bad. And then on the second one, this was also in y equals mx plus b, so I would plot my first one here. My slope of a 4, 1, 2, 3, 4, over 1, 1, 2, 3, 4, over 2. So I can pretty much tell you what my answer is, but let's just finish the graph off. So there are my two equations on the graph. It's pretty obvious right now what I think my answer is, so estimating is not as difficult as I thought. But remember, when I draw this graph, all of these points along this green line, every single one of these, not just the ones that I made nice and bold, but all these things in between are all ordered pairs that should plug in here and make that equation true. The same thing with the red points. Every single one of these as ordered pairs would be solutions to this first equation. But the only one that's a solution to both of them would be this one right here. And this one would be 1, 3. But what we have to be careful of is that we think the answer is 1, 3. But it's important that we verify that and prove it. So what I'm going to do is I'm going to take that solution and I'm going to prove that it works for both. So in my first equation, the 3 is the y, negative 2 times 1 plus 5. 3 equals negative 2 plus 5. 3 equals 3. That works. And then for the second one, if 3 goes in, 4 times 1 minus 1. 3 also equals 3, so it checks. So that means 1 3 is the solution to the system. So now we get to modeling some of this math with some word problems. These are very, very tricky with systems. We're going to be working on them throughout the chapter, and it takes some time to get used to these. But what we have to do is this. We have to first look at the problem and understand it. Then we have to kind of make a plan and see where we can get our equations to come out before we can even think about graphing. So here's the first problem. A roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for a total cost of $1,040. In a second purchase at the same prices, and that's important, the contractor buys 8 bundles of shingles for $256. Find the price per bundle of shingles and the price per roll of roofing paper. So, a couple of things. I am going to call, oh, we really bounced away from that one. I am going to call my first variable, the x's we will call shingles, and the y's we'll call the paper. It's always a good idea to kind of come up with the variables that you're going to be using, so at the end you'll know which one goes with which. So there's actually too much information here for one equation. So I'm going to need to create 2 equations to make this work. So here's my first equation. we're going to go by this first contractor that went in, and we'll make an equation out of this. So he is buying, or she, I guess, is buying 30 bundles of shingles. We don't know the cost of those shingles. And 4 rolls of the roofing paper. We don't know the cost of the roofing paper, but we know that if you added all of that up, we would get this amount, $1,040. So in the second purchase, this contractor bought 8 bundles of shingles, and the shingles cost, again, was the X for $256. So now we got to figure out, well, what was the price of a single bundle and what was the price of a single roll? So what I have to think about is, well, what do I do with these things to kind of come up with my equation? So by using the graphing method, I've got a little bit of work to do here. And because it's the graphing method, there's actually 2 ways I can do this, right? The first one, I could use my standard form, ax plus by equals c, and graph my intercepts. The problem with that is, if I use my intercept for the x-intercept, I'm going to get a really weird number, and it's not going to be a nice terminating type of decimal, so it's probably not the best one to use. So I think what I'm going to do is turn it into slope intercept, or y equals mx plus b. So let's do the first one, and then we'll talk about the second one. So if I was to bring the 30x over, let's just kind of do it here. So I'm going to get 4y equals negative 30x plus 1040. Then we know to divide by 4 across all of these. And this is going to give me y equals negative 7.5x plus 260. And then when I look at the second equation, I think will end up being a pretty easy one to kind of work on. So if I was to take this one, all I would have to do is divide by 8. And when I divided both sides by 8, this one is going to become 32. So these are the 2 graphs that I'm going to want to graph. X equals 32 and y equals negative 7.5x plus 260. Now I will tell you in a later section, what we're going to be doing is showing you a better way or a better method to solve this, especially because of the negative 7.5x. That's going to be a little bit hard to graph. Doesn't make it the best way with the graphing method, but we want to show you how it works. So here I'm going to do my graph. We're only going to focus in the first quadrant, since you can't buy or have a cost of shingles and rolls of paper of a negative amount. So here's what I've done with the graph. It's not as neat as I would like it, but just so hopefully you can see how it would work. So down here on the x-axis, we call this the amount of money per roll of the tape. I'm sorry, the paper, the shingle paper. So I went by scales of 4 because I'm seeing this number here, the 32, that I need to think about. So I'm going to go by 4 scale. On the y-axis, this one's going to be a little bit trickier. And again, this is probably not the best method for this one, but a couple of things that I tried to take into account. 260. Well, I don't really have enough to get 20s in here. And to be honest, 20s really aren't ideal anyhow. This number right here is my slope number. So for every $1 for the roll of roofing paper, it's going to be coming down 750. So here's my reasoning on this. I have a 4. If I was to come down 4 here for my x, it's going to change this by 30 each time, because 750, 750, 750, and 750. So I'm trying to think my rise over my run. Okay, so let's first just graph the easy one. The easy one, which doesn't maybe seem like the easy one, is this one. X equals 32. So what does x equal 32 look like? Remember, a line that is perfectly vertical, straight up and down, at x equals a constant would be the graph of x equals a number. So there's my first equation, the x equals 32. The next one I have to be really trying to get as best I can here. So if I look at this, my y-intercept, and this is part of this problem with this graphing method, is it's probably around there someplace. But now I'm going to try to use this negative 7.5x to help me. My slope is going to help me. So normally that means come down 7.5 and forward 1. I'm going to come down 30 and go over 4, which is the same slope, but it will help me with the scale of 4s down below. So if I was at 260, I'm now going to come down to 230 and go over there. The next one, if I come down another 30 and go over 4, I would be right there. The next one would come down and go over to be about there. The next one would come down and be about there. So you can kind of see the line that we're drawing. So this is the best I can do. Not too bad. So obviously if we had a graphing calculator, this would be a much easier problem to solve. We want to be as accurate as we can. So very clearly we can see where we're crossing, which on the graph is crossing right there. The problem is, in this way of this method, by doing it by hand, it's hard to see what the ordered pair is that's there. So I'm going to kind of help us out a little bit. Well, we can clearly see that the x value it would have to be crossing is at 32. What I'm going to say is, looking at that intersection point, it's just below the 25. So I'm going to go with the idea that it's about 20. Now, obviously, I know the answer to this, so that's probably a little bit of a leading question, but you can see that it's below 25. So I can clearly see that this is not necessarily the best way, because what if you did it and you thought, no, I think it's 22, or I think it's 15. So it's not the best way. But we still want to verify this to make sure that it is still an answer that we are trying to come up with. So to verify if we think this is our answer, and we're going to go with this for now, I go back into my two equations. So the first equation we were working with, and we want to always go back into our original equations, is we had 30x plus 4y, and the bill came to 1,040. And if I do this out, I would get 960 plus 80. Does that equal 1,040? And it does. So it works for the first one. But again, remember, it has to work for both. So if I now switch to that second one, we said that that one was 8 times x equals 256. So 8 times that 32, does that give me 256? And it does. And that would tell me that my answer was 3220. Now, 3220, what is that? What is that for an answer? Because that's not really telling me anything. So the question was, what is the price per roll of shingles? So To carry this forward for my final answer, it is $32 per bundle of shingles. And it is $20 per roll of paper. So, like I said, we're going to show you some other methods to solve these. There's another method that I would have picked over this method for this one, but that is how the graphing method works. You draw your two equations on the exact same coordinate plane, you look for their intersection points, then you verify that that point works for both equations, and then that would be the solution to your system. Be careful with your graphs, nice and straight lines, always using a straight edge. And if you have any kind of questions on this, please feel free to ask me when I see you in class.